big honking amp here is my Tubelab Simple SE. So Tubelab is a little outfit, just a one-man show. He designs and sells tube amp PCBs. This is one of them right here. This is his Tubelab SE. It's already partially built. It comes with no parts, just a blank board. This was actually his first product, the Tubelab SE. SE stands for single-ended. And this was a sort of a hybrid solid-state vacuum tube design that used 45s in the output stage. And I actually have another one up on a breadboard that is still waiting for me to build a chassis, but that's a totally different story. So anyway, the Tubelab Simple SE, if you were to buy it, it just comes like this, a blank board minus the parts. And you have to do everything else. So you have to order all the parts for the board, you have to build a chassis, and put it all together. So this is the chassis that I built for it. My original plan was to build, for some reason I was inspired by the look of like a car stereo amplifier, and I actually had an old dead car amp that was pretty big, and I could have used it as the chassis for this, but it wasn't quite thick enough and it wasn't quite deep enough, and I ended up buying these gigantic transformers for the output and the power, and it just wouldn't fit. But for some reason I was stuck on that look, so I ended up sort of improvising and building one myself. So these four fins on the side, those are actually just U-channel from the hardware store, epoxied together and painted. And I'll throw up some pictures to show you the raw pieces. This aluminum top is from a surplus place that was selling aluminum by the pound, and the rest of the aluminum is just angle iron and plate stock that I got at my local hardware store. So the Simple SE, the reason that's why it's called Simple is it is a very straightforward single-ended design. It doesn't have any fancy solid-state drivers like the board I just showed you, the Tubelab SE. It uses cathode bias, automatic bias. It's very flexible. You can run, so I have a couple of EL34s in here right now, which give you around 6 or 8 watts of output. And you can also put some KT88s or KT100s, or even bigger, the KT120s if you want, tubes on here. You just have to adjust the cathode resistor and obviously your plate supply. So I built mine to be as flexible as possible. I can run an EL34 all the way up to a KT88, and this little knob right here adjusts, it selects the cathode bias. There's a bunch of resistors on there, and I can pick which one I want and how hot I want to run the tube. Cathode bias is different than fixed bias. If you saw any of my other videos of pretty much any of my other amps, the bias is like the sort of idling operation point of the tube, like how on the tube is. So for my UK folks, they call these valves, and it's actually a good name because they act just like an electric valve. You can turn them on or set them in between or turn them off. So a single-ended amp is a single tube per channel with the tube sort of half on when it's idle, and then it turns on more or turns off more to follow the wave that is the music that it's reproducing. And because of the current that has to go through the tube, and that's compared to a push-pull tube. So on a push-pull tube you've got, or a push-pull amp I should say, you've got two tubes or transistors or whatever. One's pulling and one's pushing, and when the signal is 0, both of them are off or very slightly on, and they're more efficient. This one is always half on and goes from full on to full off depending on how loud the music is. And because there's so much current running through it and there's no other tube on the other side to balance it out, the output transformer has to handle a lot of DC current, which is why they're so huge. So single-ended amps will always have much larger transformers than a push-pull amp of equivalent size. In reality, these are overkill for this amp. These transformers are made by a company called Edcore here in the United States. And in terms of bang for your buck, you really can't do much better than these. These are really nicely made transformers. They have really great specs. The interleaving of the windings is done well enough that they have very good high frequency response, and these are huge, so they have really awesome low frequency response too. This thing can really thump. So this is the power transformer here, which is equivalent mass, but it's not an output transformer, it's a power transformer. This is an auxiliary capacitor. It's a motor run capacitor. It's a film and oil cap, and it just supplements the electrolytic that smooths out the B plus power supply, the plate power. It's a somewhat hybrid design though, so it uses a single 12AT7 as the input and driver stage, and it's plate loaded with a solid state current regulator, and the combination of having a current regulated plate with the amplification, voltage amplification of the tube gives you both voltage gain and current gain, so you can drive the output tube with a single stage very effectively. And this is just the rectifier. It's a full wave rectifier, a GZ34 equivalent. And I also added these switches here to, so there's a bunch of different ways you can set up the board inside. He gives all these different options for what you can do. You can get rid of the tube rectifier and have a solid state rectifier right on the board. And I did both, so I just throw this switch and it switches over from the tube to the solid state. You can also decide how you want to run the tubes. So you can run them in ultralinear mode, where there's some feedback coming back from the where the tube is a pentode and you're getting some feedback from the transformer. You can also do pure pentode, but it's not the best, not the most linear setup. Or you can run the tube as a triode, where you attach the screen to the plate and then the pentode acts like a triode. So if I throw this switch, it goes from triode to ultralinear. And then this last switch is a local feedback. So there's you can take the output from the output transformer and feed it back locally to the output tube's cathode, because these are cathode biased output tubes. They're elevated, and you can actually feed an AC signal back and get some feedback. And what that does is it would compensate for the performance of the output transformer, but it almost has no effect on mine because I have such a huge output transformer. There was really no problem with bass response. But if you chose a smaller transformer, save some money, get a transformer that's not so big and maybe lacking in the very low bass, you can throw this switch and it would give you some local feedback. It would reduce your gain a little bit, but it would flatten out the bass response. And on the front here, I've got a couple volume knobs, which I usually just leave full, power switch, and the indicator light. So I built this thing in 2011, so that's about 7 years ago, and it has been completely trouble-free. I had to take it apart one time to replace a capacitor, the bypass cap on the cathode of one of these. I had a Tungstol reissue 6550 tube in here, and the grid shorted to the screen, and it fried the resistor and blew the capacitor, but that was it. So it wasn't the amp's fault, it was just a bad tube. Oh, and back here I have these little banana plugs, and because of my adjustable cathode bias, I made it so I can hook a meter up and actually measure the voltage across that resistor to just kind of double check. So when I put in a tube that I'm not familiar with, or I don't remember what setting I should use, I can just throw a meter on there and measure the voltage across it, do a little math, and I can figure out how much current's running through the tube. So anyway, I'm just going to do a little bit of service on this guy. Like I said, I haven't taken it apart. That tube failed like less than a year after I built it, so it hasn't been apart in 7 or 8 years, and I want to take a look inside and see how it's doing. I use this in my main system for my main speakers. I have a pair of Klipsch KLF10s, which are very efficient speakers, so 8 watts is plenty to drive those. And so I have EL34s in there right now. These are the Winged C or SED said EL34s. These are really beautiful sounding tubes. I think I'm going to swap them out though for some other tubes right now because I want to save these. So you can see how the tube sockets are recessed. I like the recessed look. Aesthetically, it brings the tube base down and kind of hides the socket a little bit. But it actually has a practical purpose. So this black plate that you see here is an aluminum plate that's just sitting right above the circuit board, and there's an air gap here. And that's actually open, so the plate sort of just goes like this, and then air can flow in from the chassis. And what happens is these turn into little chimneys. The heat from the tube envelope creates an updraft of hot air, which pulls air in from inside. And there's an opening on the back that lets the air draw in. So that's one of the things I want to look for. I want to clean out any dust bunnies that might be in there because it actually flows really well and keeps the circuits inside nice and cool. So I've got the amp flipped over now, and you can see the back of it. These are the speaker terminals and the inputs, fuse holder, power socket, and so you can see there's a big air gap here, and this is actually my air intake. It's somewhat unintentional, but it worked out well. Again, this thing is built out of hardware store aluminum, so this is just a piece of 2-inch aluminum angle iron that I trimmed and cut and drilled and all that business. But the height of this thing after I glued those U-channels together was more like 2.5 inches or so. And on the front I made a little blue strip. It looks like a stripe, but it's actually a separate piece of metal that I painted the same color as the ED cores. And the back I just left it open because it's the perfect air intake. But little fingers can get in there. But it's in the back. It's in my system in the back. You can't really get to it, so I'm not too worried. And there's really everything's insulated in there, so there's nothing you can really get to. All right, so let's crack this thing open. When I built this chassis, it just took forever. I don't enjoy chassis work, and this thing was just so much milling and drilling and filing and cutting and measuring and drilling again, and it took a long time. But it worked out pretty well. It came out nice. I was very happy with it. There we go. So this is a choke. This is an optional component that you can add if you read the instructions for the Simple SE. Again, here's the circuit board. This is all you get is this green board right here. You can just use a series resistor, or if you add a choke instead, it smooths out the DC even more and makes the plate supplies even quieter. So this right here is my little heat sink. So like I said, there's two current regulation devices on the plates of the 12AT7, and so what I did was I wanted to move that heat over to the finned side of the chassis over here. So I just made this little bracket to do that, and it does. This side gets warmer than the other side, so it does do its job. But it only gets warm. It doesn't get anything close to what I would describe as hot. So as you can see, there's quite a bit of wiring in here. All those switches that I talked about with all those crazy options. The end result is you end up with a lot of wires going back and forth, and it's actually pretty confusing to get it set up right. These are the input wires here. They're just a twisted pair from a Ethernet cable. Ethernet cable makes great twisted pair audio wire if you don't need the actual shield, because this is all enclosed in metal, so I don't need to worry about that. They're Teflon insulated usually, the good stuff, and yeah, it makes pretty good audio wiring actually. The coupling caps between the driver and the output tubes are ARA caps. Again, I like these capacitors. They're fairly inexpensive, well made, and relatively transparent. And you can see if you follow the instructions and use the bill of materials that he suggests, you get these nice screw terminals everywhere where the wires come to the board. You can solder the wires directly to the board if you want to save money on that, but for as complicated as this thing is, I wanted to make it so that I could easily pull it out and work on it if I needed to. And it was also a little hedge against Murphy's Law, because if I made it so I can work on it, I wouldn't have to work on it, because it would be fine. So this is the high voltage wiring from the power transformer going to the well, actually, no, the yellow ones are the 5 volts for the rectifier, and the red ones are the high voltage. And these are the solid state rectifiers here. They don't do anything unless I throw that switch. And what you get if you do that, if you throw that switch and pull out this tube, taking the load off the 5 volt supply for the tube filament takes some load off of the power transformer, which raises all the other voltages a little bit. And then also the voltage drop across the diode is much less on the solid state than it is on a tube rectifier. So you get a bit more voltage on the plates, so you get a bit more output if that's what you want. I hardly ever use it though. Here you can see another piece of 2-inch angle aluminum, and these two are just there to support the weight of those super heavy transformers. This over here is my star ground point. The ground from the outlet comes here, and then the ground goes to the a single wire goes to the circuit board, and there's a single ground point on that. And he's really good with layout. He knows how to make sure you get no ground loops in it doesn't pick up any hum. This thing has 0 hum. It's dead quiet amp. And I have another ground strap over here. This is just a safety ground. I wanted to make sure that the front panel, because everything was painted, so it's possible that the screws wouldn't cut through the paint, so I wanted to make sure the front panel was grounded. So I just kind of loop it through here and ground to this, which is where my other ground point is. And here you can see the underside of the motor run capacitor, which just sits in parallel with this cap right here. This is the main capacitor for the power supply. And you can see on the capacitor, maybe you can't see it on the camera, but there's a coating of dust just on this side. That's just from the airflow coming through. Let's wipe it off. But yeah, there's no dust bunnies in here, so I'm happy about that. Oh, this right here is an Inrush limiter. So this these are kind of cool. These are little thermistors, and so they're designed to sit in parallel or in series with your load. So how it works is when it's cold, they're several ohms in resistance, maybe 10, even 20 ohms. And then because they're a resistor, once you start flowing current through them, they start heating up. And because it's a thermistor, the resistance goes down the hotter they get. So what effectively that means is you have a series resistance in the circuit when you first turn the unit on, which brings up all the capacitors slowly. And then this thing starts heating up from that current flowing through, which makes the resistance go down, and it basically kind of takes itself out of the circuit and ends up being like a few tenths of an ohm once it gets up to temperature. And that's just to save the well, it helps the tube rectifier when you throw that switch wherever you are in the 60 hertz of your outlet. It's an instant straight up on, and that's tough on the rectifiers, and it's also tough on the caps, and it also makes a thunk, and it makes a pop. So this thing kind of suppresses all that. So I mentioned before that I can adjust the cathode bias on this amp by turning that rotary switch on the top, and you can see the bottom of it right down here, and you can see these resistors kind of behind this here hanging off of it. This is one set of them, and there's another set on the other side here underneath the board. And the way it works is there's two 680 ohm power resistors that are always in the cathode circuit, and they're strapped to this beam here down in here. And then when you throw the switch, it moves different resistors in parallel with that one. There's a 750, a 910, a 1.2K, 1.5K, and 3.3K, and then nothing. And that just lets you reduce the 680 down to as low as I think 340 or so, and which is perfect for a KT88. So I just wanted maximum flexibility, and I wanted to be able to tube roll without having to take the amp apart and fiddle with things, and it lets me do all that. So this is not the most detailed amp, detailed sounding I mean. The really large output transformers, I think you lose some detail in them just due to their sheer mass. It seems like even with EL34 and triode mode, it's sounds really great, but it's not quite as good as my Tubelab SE, which, like I said, is still on a breadboard, but I have listened to it quite a bit. That one uses 45, so it only puts out like 1.5 watts, or with 300 Bs it'll put out about 3 or 4 watts. But the transformers I used on that amp are much nicer transformers, and the amp overall is much more detailed than this amp. Not much more, but noticeably more detailed. Now, with this amp, if I put some KT88s in there, I lose even more detail, but I gain more power, and boy, this thing can really thump. The bass it can put out is amazing, especially with my efficient speakers. So anyway, I don't really have much more to show you. I'm not going to take it any further apart because I have no reason to. The caps all look fine. There's no sign of distress. There's no burnt spots on the board. I don't think I have any thermal issues with this amp at all. It's not nearly as dusty inside as I was expecting. There's a little bit of dust here and there, which I'll blow out before I put it back together. So yeah, this is the inside of the Tubelab Simple SE. I'm putting these Valve-Art EL34s in here instead of my said Wing C amp EL34s. These are just Chinese-made tubes. Valve-Art's just a brand that imports them. You can buy these Chinese tubes really cheap. I don't know if these are made at the Shaogung plant or one of the others, but I've learned my lesson. Don't buy the ones off eBay. If you see Chinese tubes for cheap on eBay, what you're buying are the factory rejects. So when those Chinese tubes get a fancy label stamped on them, they do jack up the price and you pay more from whoever you're buying them from. But what they've done is they've not just tested the tubes, but they've binned them. They've tested them, made sure they're in spec, and picked the better ones and put their stamp on them. And all the ones that failed those tests, even though they may still be functional tubes, those end up on eBay. So just a word of warning, I've been burned. So here's a KT88 tube. This is a Winged C SED / Svetlana, formerly known as Svetlana, KT88. If you see a tube branded Svetlana, it's not one of these. It's made by New Sensor, same ones that make the Tung Sol and Millard relay shoes. This one's made by a different factory. It's made in Russia, but it's a totally different company that is no longer in business. But these were probably some of the last really great tubes from one of the last old factories in recent history. Compare the size of that to this little EL34 here. It's also the said EL34. So yeah, big difference in size, but on this amp it'll handle either one. So you can see the KT88s are right at home. And all we gotta do is crank the bias all the way up, -1, and boom, 14 watts instead of 8. Right, so this is my Tubelab Simple SE, my main workhorse amp and my main system. See how it sounds with these KT88s.
I was a little too tall, could've used a few pounds. Tight pants points hollering out. She was a black-haired beauty with big dark eyes, and points on her own, sitting way up high.